Let's look at this question. The question says a cell has electromotive force E in volts and internal resistance of R in ohm. Okay, when resistors of 2 ohms and 5 ohms are connected across its terminals, current of 0.5 ampere and 0.25 ampere are passed. Calculate the value of E and R. Now, this E represents the electromotive force while the R represents the internal resistance. Whenever you see a question like this, the first thing you need to do is for you to either you interpret your questions or you draw a cell. So we prefer you draw your cell. Okay, now let me draw my cell. Okay, now the question says a cell has electromotive force. A cell has electromotive force. Okay, this is my internal resistance. Now, electromotive force of E in volts. So in the place of electromotive force, I'm going to write my E. An internal resistance R. In the place of internal resistance, I'm going to write my R. Okay. When a resistor of 2 ohm and 5 ohms, that means in this case, that means the cell must have been 2. So you draw another cell. Draw another cell. Okay. Now in this case, when a resistor of 2 ohm and 5 ohms, so I come to this place, I have my 2 ohm here and I have my 5 ohms here. So my electromotive force is E and my internal resistance is my R. Now they say current of 0.5. So in the first one I have my current of 0.5 ampere and 0.5 means in the second one I have my current of 0.25 ampere. As simple as so I can name this one my A and name this one my B. See? So the next thing you need to do is let's focus with the A. Using the formula from A, from my A, using the formula. Come on. Using the formula. The formula that really fits into this question is my E equal to my I, which is my current, into R plus I plus R. In this case, what you need to do is for A, electromotive force is unknown. What is R? Sorry, what is I? The current 0.5 into what is R? R is 2 plus what is R? R is the small r is not given, which is the internal resistance. So I'm done with my A. So I can choose this to be, I'm done with my A. Okay, so I can choose this to be my equation 1, 2, my equation 1. This can be my equation 1. Then let's focus on B. For B, okay, for B, for B, for B, the same thing you do using the formula. Now, I'm going to have my E equal to, what is my I? For the second one is 0.25 into R is 5. R is 5 plus the small r. So this can be my equation 1, equation 2. So now, looking at this, since E is equal to this and E is also equal to, that means E can be equal, this or this, the E in A can be equal to E in B. You see? So therefore, I'm going to equate this one to this one. So I'm going to have something like 0.5 into 2 plus R equal to 0.25 into 5 plus small r. Do you understand? Since E is equal to this, and the same electromotive force is equal to, so I can equate this equal to this. That's what I'm doing. So now, by solving all this, what's my 0.5 times 2? I'm going to open the bracket now. By opening the bracket, I have 1 plus 0.5r equal to, I have 1.25 plus 0.25r. By collecting like terms, okay, I'm going to have, by collecting like terms, I'm going to have my r equal to 1 ohm. Okay, by r equal to 1 ohm. So now, okay, from equation 2, I can use any one. I can use either equation 1 or equation 2, all the same. From equation 2, which is this. Find your E. Find E. Find E. So my E is now equal to, what do you have in equation 2? I have 0.25 into 5 plus R. Okay. Now in this case, I have 0.25 into 5 plus, what is R? R is 1 plus 1. So in this case, you can have something like 0.25 into this plus this is 6, right? Is 6. So now, if you multiply 0.25 by 6, it will give you nothing. Wait, it will give you nothing but 1.5 volts. 1.5 volts. That is the answer. So thank you so much for watching. Thank you so much for watching. You can subscribe to my YouTube channel and share the video.